if you're not comfortable with the product, quotient, or chain rule, then we suggest that you go back and get a little bit more familiar before looking at this video. So let's start with an example. In this example, I'm going to show you simplifying as a technique to make the derivative easier. So if you notice, this is actually the difference between two perfect squares. So we can factor this as so. We can say x squared minus 1 times x minus 1, times x plus 1. And if you want to make sure that this works, you can quickly factor that out and see that it equals that, all over x plus 1. And now that we have this, you can see that we can cross these out. So now, all you have to find the derivative of is x minus 1, which, easy enough, is just 1. If you want to see that this is better than actually doing the quotient rule, Tatiana and I will be having an epic race.
Hi, this is section 2 of our video on simplifying before you derive. Things to make your life easier when you're doing derivations of functions. In the last section, you probably saw Tionney kick my butt in a little epic race, and this round I'm going to beat her, but first I have to show you the trick that I'm using. It's another way to simplify before you derive. So here's what it looks like. Say you want to derive d dx of the function 2x times x minus 1. Now, it looks like the product of two functions, and truly it is. But these two functions just so happen to have a quality wherein you can distribute this function into this function. They're just so nicely related that you can make them share like that, and then they become just one function. I'll show you what I mean. Basically, 2x times x minus 1 equals 2x squared minus 2x. So with this fact, we know that this derivative that we're looking for has got to equal the derivative of 2x squared minus 2x, which is easy enough to derive, isn't it? We just use the power rule. So that is 4x minus 2. And now, kindly watch as I rematch with Tionney.